Hello, Matthews Gatos here. In this video, we're going to cover sections 3.2, but before I do that, I'd like to review section 3.4 with a couple of diploma examples. Okay, looking at this one here, they've given us a graph of a polynomial and they want us to write the equation of it. And in particular, they're going to ask us for what the a value is. So when I look at these, I look at my x-intercepts and I list them out as my roots. So when I have an x-intercept at -6, I know that my root will be x plus 6. When I have an x-intercept at -2, my root will be plus 2, and a root at x at 2, 0 is going to be a root of -2. So I start to build my equation like this. Then I look at the multiplicity of my roots. So looking at the multiplicity of my roots, this at -6 is just passing through, so I know it has a multiplicity of 1. At -2, it is passing through, so it has a multiplicity of 1. And at +2, it does a touch and turn around, so the multiplicity is 2. So I want to put this together to solve for what my a value is. So presently I have y equals a times x plus 6, x plus 2, and x minus 2 squared. So the next place that I go is into the graph, and I look for a point other than the x-intercept. For example, this y-intercept. So I substitute in x for 0 and y for 96, and then I can solve for x. Okay, so I have 96 is equal to a times 6 times 2 times -2 squared is 4. So I end up with 96 is equal to a times 48, and then divide both sides by 48, and I get an a value of 2. Okay, in my next diploma question here, I want to come up with some statements about the minimum possible degree and the leading coefficient. So first one says I have a factor of x plus 2 with a multiplicity of 3. So that means at x equal to -2 with a multiplicity of 3, I have a curve change or a point of inflection. So it might be like this, or it might be like this, but at -2. I'm told that the value of my polynomial when x is 0 is -24. That's just a y-intercept. And that I have a minimum value at -66. So let's just do a little sketch of what this would look like. So not drawn to scale, but I have my x-intercept there at -2. I'm going to really extend this. I have my y-intercept at -24. And then all the way down here at -66, I have a minimum value, which means my graph does not go below that point. Okay, so I have to decide which one of these points of inflection there are. And I can see looking at my graph, the only one that makes sense is this one here, because I have to come through this graph and I have to go through the y-intercept and then I turn around. So I'm envisioning that the graph looks something like this. I come down, point of inflection, go down through my y-intercept, and at some point, I don't know exactly where for my x value, I reach a minimum value and I have to bounce back up and go in that direction there because I can't go any lower than that one. So if you look at this sketch here, this one here has a multiplicity of 3, and since I'm just passing through, that has a multiplicity of 1, and 3 plus 1 is 4. So my degree is 4. Now looking at the way my end behavior goes, degree of 4, see that both my arms are pointing up, it's opening up, which means that I must have a positive leading coefficient. So the only row that makes sense is row A, where the degree is 4 and the leading coefficient is positive. So in this video, I'm going to cover the remainder theorem. So we're going to be looking at the relationship between polynomials, long division, synthetic division. We're going to be looking at the relationship between the remainder of a polynomial divided by a binomial and the value of that polynomial at that root. So let's look at long division. So a little acronym that I use to help, especially my elementary students, learn or remember the steps for division is, does McDonald's sell burgers, Ronald? So that acronym really stands for divide, multiply, subtract, bring down, and repeat until remainder. So I'm going to use these steps here when I'm doing my division. So I want to start with just a question that has numbers in it, and then we can move to doing polynomials. So if I had something like this, following the steps, 2 goes into 173. So the first thing I do is divide. So I do 17 divided by 2, and I get 8. And then I multiply. 8 times 2 is 16. And then I subtract, which is 1. And then I bring my number down to get 13. And then I repeat this process until I get a remainder. So looking at the parts of this, the 2 outside here, this is called your divisor. That's the number that you are breaking the dividend into equal parts. So the dividend of 173 is divided into parts of 2. The number 86, that's the answer to a division question, which is called the quotient. And of course, you have your remainder. So in ways of writing a division statement, the first way is I can take my dividend, 173, and that will be equal to my divisor multiplied by my quotient added on my remainder. So this is the way that I think most of us think of a division statement. 173 is 86 times 2 plus a remainder of 1. However, another way of writing it is just by dividing each of the terms by the divisor. So if I divide everything by 2, canceling there, I end up that 173 over 2 is the same as 86 plus 1 out of 2. So I want you guys to write it both ways so that we're familiar with both ways of writing. So let's look at now polynomials. So we're going to show you how I got all of these parts of the question in a little bit later, but I want to talk about just the steps here. So the x minus 2 is called the divisor. What's underneath the division statement is called the dividend. So I'm taking this polynomial x squared plus 2x plus 4, and I'm dividing it by x minus 2. So the answer is the quotient, so that the quotient is the answer to a division question. And of course, you have your remainder. So putting this all together, I can have that my dividend is equal to the quotient times the divisor plus the remainder, or divide each term by the divisor of x minus 2, canceling out, and you get that the quadratic divided by x minus 2 is x plus 4 plus 12 pieces out of the divisor of x minus 2. So that's how you write the division statements. Let's look at how I actually get the parts of the long division to come up with the division statements. So in this example here, I want to divide 2x cubed minus 4x squared plus 3x minus 6 by x plus 2. So the very first thing that I notice is that I have all my terms in descending order of x, and there is no term missing. So I went cubed, squared, 1, and none. So everything is accounted for. So let's follow our steps. Step 1, divide. So I'm going to use the leading coefficients, the leading terms to divide. So 2x cubed divided by x is 2x squared. So I've done my division. Now I do my multiplication. So 2x squared times x, and then 2x squared times 2. So I've done my multiplication, and now I subtract. So 2x cubed take away 2x cubed is 0. Negative 4x squared take away 4x squared is negative 8x squared. And then, since I've done the subtract, I go to the bring down, so plus 3x. Okay, so again, looking at your leading terms. Negative 8x squared divided by x is going to be negative 8x. So negative 8x times x is negative 8x squared. Negative 8x times 2 is negative 16x. And then again, I subtract. So negative 8x squared take away negative 8x squared is 0. 3x take away a negative 16x is a positive 19x. And then I bring down my last one. So you repeat until remainder. So 19x divided by x is 19. And then now I multiply. So 19x plus, and then 19 times 2, 38. And then I just subtract to finish this off. So 19x take away 19x is 0. Negative 6 take away 38 is negative 44, which is my remainder. So I want to write this as a division statement in the two different ways that we talked about. So here's what I ended up with, my quotient, 2x squared minus 8x plus 19 with a remainder of negative 44. So the first way is the quotient multiplied by the divisor, add on the remainder. And then the second way is just divide each of the terms by the divisor, which is x plus 2. So you can see I divide everything by x plus 2, and you're left with, after this canceled, the answer being 2x squared minus 8x plus 19 minus 44 out of the divisor. So we want to be comfortable with both ways of writing it. I'm a big fan of the check, as you all know, so here is my original question into y1 and how I think it is factored, or the division statement into y2. So this is way number 1, just because I think it's a little easier. You could put in division statement 1 or 2 in there, but you can see the check always happening in the table. I know that I'm correct. Let's try another example. In this one here, I'm going to have a cubic function divided by a binomial. Now, the first thing I notice, there's something that's missing here, and that is a 0x. There is no x. So if something is missing, record it as a 0 because it will make the division much easier. So I have 3x cubed minus 2x squared plus 0x. So have that in there, plus 1. So let's follow our steps. So divide. Use the first term to divide. So 3x cubed divided by x, 3x squared. So I've done my division, now I multiply. 3x squared times x, 3x squared times negative 2, and now I'm ready for subtract. So 3x cubed, take away 3x cubed. Negative 2x squared, take away negative 6x squared. So when I subtract that, I end up with 4x squared, and then I bring down my next term. So I just continue and I repeat until remainder. So 4x squared divided by x is 4x. Multiply 4x times x. 4x times negative 2. And then I subtract. So I have 0 here. And then 0x take away a negative 8x is just positive 8x. And then I'll bring my last term down here of 1. So 8x divided by x is 8. And then I multiply and subtract. 8x take away 8x is 0. 1 take away a negative 16 is a remainder of 17. So now that I have my division, I can write this as division statements in the 2 different ways, and of course check on the calculator. So here's my first way. I take my quotient multiplied by my divisor, add on my remainder. And then in the second way, divide each of the terms by x minus 2. You can see those cancel. And you're left with 3x squared plus 4x plus 8 plus the remainder out of the divisor. So just the 2 different ways. I'll use way number 1 to check it on my calculator. So original question, way number 1 entered in there. And you can see the check always happening in the table. And it works out so I know I'm correct. Now, long division is fine, and if you like to, some students like to stay with long division, but it can be a little bit tedious. So I want to take that example that we just did, and I want to look at a different way that we could do it, called synthetic division. So synthetic division is just a shorthand way of dividing without using the variables. So imagine that we just got rid of all the variables. So if I took this here, I'm going to get rid of all the variables, and I'm going to do this shortcut way of dividing. So negative 2 is going to go on the outside, and on the inside are all of my coefficients. So 3, negative 2, 0, and then of course my constant of 1. So I'm going to follow the same process that I do with division. I'm just going to do them with numbers instead of variables. So I bring the 3 down, which is 3, and then I multiply. Negative 2 times 3 is negative 6. And just like long division, I subtract. So negative 2 take away negative 6 is positive 4. And then negative 2 times positive 4 is negative 8. And I subtract. 0 take away a negative 8 is a positive 8. Negative 2 times 8 is negative 16. And then 1 take away a negative 16 is a remainder of 17. So look what we ended up getting. We got a 3, a 4, an 8, and a remainder of 17. So this method works, and it's a lot simpler. So in order to fill these in, I read from right to left, so going backwards. So my last number is my remainder. Then I have my constant, I have my x value, and my x squared value, okay? And I can see that it matches. Everything matches up. So let's try this process again. So here, 2x cubed plus 4x squared minus 3x plus 4, all divided by x minus 2. So looking at this, I have all my terms. Everything is there and it's in descending order. Nothing is missing. So I'm good to go. So let's erase all of our x values. And we're only going to use our numbers. So instead of dividing by x minus 2, I divide by negative 2. And here I have a 2, a 4, a negative 3, and a 4. So I shouldn't have scratched that one off because that didn't have a variable. There we are. Okay, so we bring this down as 2, multiply negative 4. So 4 take away negative 4 is 8. So multiply is negative 16. And negative 3 take away a negative 16 is positive 13. And then I multiply and subtract. 4 take away negative 26 is 30. So I just want to build that from right to left, starting with my last number, which is my remainder. This number is my constant, and then I have x and x squared. So I can write this together as a division statement. So my polynomial, my cubic polynomial, is my divisor, x minus 2, multiplied here by my quotient, 2x squared plus 8x plus 13, add on my remainder of 30. Or divide everything by x minus 2. It would cancel in this one, and I would end up with way number 2. Okay, let's try another one. So in this one here, I've got a cubic function, again, divided by a binomial. So I notice I have something missing. I have a 0x that's missing. So again, we don't need our x values, so scratch those out. So I'm dividing by negative 2, that goes there. And then I have a 3, a negative 2. I'm going to record a 0 for x and 1. So bring the 3 down. Negative 2 times 3 is negative 6, and I subtract them just like I do for long division. So negative 2 take away negative 6 is positive 4, multiply, and like division I subtract. 0 take away a negative 8 is a positive 8. Negative 2 times 8 is negative 16, and 1 take away a negative 16 is 17. So again, reading this from right to left, I end up having my remainder, my constant, my x, and my x squared. So let's write that as a division statement. So there my cubic function is x minus 2 multiplied by the quotient, 3x squared plus 4x plus 8, with a remainder of 17. Or again, I can divide all my terms by x minus 2 to get up with my second division statement. So this brings us to the remainder theorem. If I have a polynomial that is divided by x minus a, that's the factor, then the remainder is going to be the value of the polynomial for a, meaning x equal to a is the root. Well, let's just check how that actually works. Let's go back to that last question that we just did. Okay, I want to check if that's true. Am I going to end up with a remainder of 17 if I put the value of my polynomial into that equation? So my expression was 3x cubed minus 2x squared plus 1, and I'm dividing it by x minus 2. Now, using what the remainder theorem says, if x minus 2 is my root, my factor, x equal to 2 is my root. So I'm going to take that and substitute it in there, and according to the remainder theorem, I should end up with 17. So let's just check if this works. So 3 times 2 cubed minus 2 times 2 squared plus 1. So 2 cubed is 8, and 8 times 3 is 24. 2 squared is 4, times 2 is 8, plus 1. So I end up with 25, take away 8, which, lo and behold, it is 17. So it looks like this remainder theorem works. So let's try that with this question here. So again, I'm going to take my factor and substitute in my root. So I want to know the remainder when this polynomial is divided by x minus 2. So x minus 2 is the factor, which means x equal to 2 is the root. So let's substitute that in. So 4 times 2 cubed minus 11 times 2 squared plus 12. And I want to work this out to see what happens. So I'm going to have 4 times 2 cubed. Well, 2 cubed is 8 times 4 is 32. Minus 2 squared is 4 times 11 is 44. Add that to 12. And that is a remainder of 0. So that means when the cubic is divided by x minus 2, it has a remainder of 0. Now, just looking ahead to our next section, if I have a remainder of 0, that means that x minus 2 is a factor because there's nothing left over. So just as a little look ahead, since the value of the polynomial equals of x equal to 2 equals 0, that tells me that x minus 2 is a factor. Again, we'll deal with that more in the next section, but good to look ahead. Let's look at this one. So I'm going to look at the remainder when it's divided by x plus 1. So this is the factor, which means x equal to negative 1 is the root. So I'm going to substitute that in here. So 2 times negative 1 to the 4 minus 3 times negative 1 squared plus negative 1 minus 1. Notice I'm using brackets for all of my substitutions. So this tells me that the value of the polynomial at negative 1 is negative 1 to the 4 is 1 times 2, minus negative 1 squared is 1 times 3, and then minus 1 and minus 1 together is negative 2. So the value of the polynomial at negative 1 is 2 take away 3, take away 2, which is negative 3. So the value of the polynomial at negative 1 is not equal to 0, it's equal to 3, which tells me this does not go into it evenly, which means it is not a factor. So since there's a remainder, I know that x plus 1 is not a factor. But again, we will touch base on that fact in the next section. So let's try some little twists on these questions. So this time I'm going to give you the remainder and the factor, and you're going to solve for a part of the cubic function. So we have this cubic polynomial, and it's divided by x minus 3, meaning that x equal to 3 is the root, and the remainder is negative 6. Now, normally we're solving for that, but this time we're given it. So this is what I'm really given. The value of the polynomial at 3 is equal to negative 6. So let's substitute in 3. The value of the polynomial at 3 would be 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals to negative 6. That's the remainder. So 3 cubed is 27. 3 squared is 9 times k. 17 times 3 is 51 plus 6 equals negative 6. So what I really have is grouping all of my like terms, 27 and 51 and 6. That is 84 minus 9k equals to negative 6. So I will subtract 84 from both sides to get negative 90 and divide both sides by negative 9 to get a k value of 10. Okay, in my last question, I want to do this with an even bigger twist. So instead of me finding one value, I'm going to look at two values. So I don't know A and I don't know B, but I do know when this cubic is divided by x plus 1, meaning x equal to negative 1, the remainder is negative 18. So that tells me the value of my polynomial at negative 1 is negative 18. Let's start with this one first. Okay, so what this tells me is that 3 times negative 1 cubed plus a times negative 1 squared plus b times negative 1 minus 7 is going to equal to the remainder, which is negative 18. Okay, so I have 3 times negative 1 plus a times positive 1 minus 1 times b minus 7 equals negative 18. So this is a minus b. Grouping my like terms, I have negative 3 and negative 7 is negative 10. And I'm going to add the 10 to the other side to get negative 8. Okay, so these combine to be negative 10, and then to isolate for my variables, I add 10 to both sides and I get 8. Negative 8. So this is my first equation. A minus b equals negative 8. I'm going to do the same thing with my second piece of information. So the same polynomial divided by x minus 2, meaning the root is 2, the remainder is negative 3. So what that tells me is the value of my polynomial at 2 is negative 3. So let's do this again. So 3 times negative 3 cubed plus a times negative 3 squared plus b times negative 3 minus 7 is equal to the remainder, which is negative 3. Okay, so working through this, I have negative 3 cubed. Did I do this right? Just hold on a second here. No, I did not. I'm just noticing I made a boo-boo. Let's try this again. So the value of my polynomial is 2. I was substituting in the remainder. That's okay. We'll just change it. I didn't get too far, thankfully. So 2 cubed, and then a times q squared, and b times 2. There we go. Much better. So this is the value of x that gets substituted in. This is the remainder, which is what the whole thing is equal to. Okay, now I'm good to go. So 2 cubed is 8 times 3 is 24. Plus 2 squared is 4 times a, plus b times 2 minus 7 equals negative 3. So I have 4a plus 2b equals, so 24 take away 7 is 17, and I'll subtract 17 from both sides to get negative 20. Now I notice that all of these are divisible by 2, so I'm going to divide them by 2, so 2a plus b equals negative 10. Okay. So I'm going to take my 2 equations in 2 unknowns to the next page, and then I'm back to a 10C question. So I can solve this using substitution or elimination. It's set up so nicely for elimination. So I'm going to go 2a plus a is 3a, b plus negative b is 0, and negative 10 and negative 8 is negative 18. And then to isolate a, I just divide both sides by 3, and I get that a is negative 6. And then I can go up to either equation. I'm going to go up to the first one to solve for b. So I chose that one because both of them have a leading coefficient of 1. So I have a minus b equals negative 8. So add 6 to both sides. I get negative b equals negative 2. And then divide both sides by negative 1, and I get a b value of 2. Okay, so to summarize my lesson, to divide polynomials, use does McDonald's serve burgers, Ronald? Which is divide, multiply, subtract, bring down, and repeat until remainder. So polynomials can be divided using synthetic division with the coefficients or with long division. Now, without using long division, the remainder theorem can be used to find the remainder. And the reason that's a big deal is because if I don't have a remainder, I know that that binomial is a factor. So what we do is we set the divisor equal to 0 to find the root and substitute the root into the polynomial, and the end result is the remainder. I don't really like long division. I always feel so bad for the remainders because they're kind of left over. They're left out. Pretty sad. I want you guys to work on practice questions number 1 to 4. Those are in my notes. Detailed solutions, of course, are on D2L, and then move on to the textbook questions. So I hope this video helped, and I look forward to seeing you for the next one.